Hello, everyone. This is Lisa Ruggiero. I'm a program coordinator at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Find Money in the Water System Budget, Energy Management Teams, Baselines, and Data Collection. I'm going to be providing some technical support for today's session. Please take a moment to observe your GoToWebinar control panel. Most of the functions are self-explanatory, but I'd like to draw your attention to the questions section on your control panel. During today's session, you will all be kept on mute to ensure audio quality and minimize background noise. Should you have a question, please type it into the GoToWebinar question dialog box and specify who you'd like to answer it. We will be holding all questions until the end of today's presentation to ensure that we end on time. We have over 400 registrants for the webinar today, and we will try to get to as many questions as we can. Our presenters today have consented to share their presentation slides with you, and we will make the slides available as well as a video recording following the webinar on the EFCN website at efcnetwork.org. Please allow 1 week for the processing and posting of these materials. And now I'd like to do a quick sound check. David, are you there?
Yes, I am.
Great, we can hear you, David. How about Steve?
Yes, I'm here.
Thank you, Steve. And Doug?
I'm here.
Thank you, Doug. And Dawn?
Yes, I'm here.
Thank you, everyone. And now it is my pleasure to turn the program over to David Tucker, Project Director at UNC-Chapel Hill.
Thanks very much, Lisa. I appreciate it. And all of you should be seeing a logistics slide on your screen. And the main takeaway here being that you have a chat box where you can type in questions to us. If you want to make that a little larger, you can click on that little squiggly arrow there to detach it and expand it on your computer screen. Really a delight to be with all of you here today talking about finding money in your water system budget, energy management teams, baselines, and data collection. This is a product of the Environmental Finance Center Network, a network of EFCs around the country. You'll see a list of in a moment. And this is funded by the Smart Management for Small Water Systems project, which is funded by cooperative agreement with the United States Environmental Protection Agency, where we are doing work across all of the states and territories with water systems serving 10,000 or fewer people. There also are workshops and direct technical assistance happening, webinar series on other topics such as rates and finance or asset management. And we invite you to go to the project website and check all of that out. Here's a list of the EFCs that are part of the EFC network. And we have represented here on the webinar today colleagues such as Lisa from Syracuse University EFC, Dawn from the Wichita State University EFC, and yours truly from the UNC-Chapel Hill EFC. From our areas of expertise across the network through the Small Systems Project, we are providing assistance in all of the areas you see on your screen here. You heard me mention a few of them a moment ago. There's also water loss reduction, finding funding programs you may be able to use for capital improvements and projects, working with other water systems in your region and collaborating with them, and so on. Here at the UNC Environmental Finance Center, we are dedicated to enhancing the ability of systems like your own to provide your environmental programs and services in fair, effective, and financially sustainable ways. And from Dawn's EFC at Wichita State University, they have a similar mission to provide professional training, technical assistance, and applied research through collaborative approach with partner organizations in these many areas you see on your screen here. This is the second in a series of 4 webinars on energy management and ways to find money in your water system budget to save through energy management. If you missed the first one, it is posted on the project website with the slides and the video. You can go watch at your convenience. We will be scheduling additional ones in the next quarter and couple quarters of the year on project ideas and prioritization methods, as well as special financing models, i.e., how can you pay for it? Last we checked, there's 414 registrants from around the United States, from places as far away as Puerto Rico, Hawaii, and Alaska, as well as a few folks from abroad, such as in Canada. We're really thrilled to have all of you with us here today. We have a number of great expert speakers today, and I'll be introducing them one at a time as they speak, including Doug Evans, Steve Jones, Don Null, and you already heard from Lisa and myself. We'll first hear today from Steve, followed by Doug, talking about some success stories in the state of Utah where they've used these methods, energy assessments or audits, and employing the projects and following up on those projects to save substantial amounts of money for systems out there. And my colleague Dawn will present at greater length about how one goes about doing these steps, including how to form an energy team, which can be really helpful to carry your initiatives forward across time. And then, as Lisa mentioned at the end, we'll have about 10 minutes for questions and answers and wrap up. And again, anytime during the hour that you have questions for any of our speakers, please go ahead and type them into your question box. Before we get to our expert speakers, we want to ask you a handful of questions here, and we're going to use the polling function of GoToWebinar. So Lisa's going to launch the first polling question right now. We want to get to know better who you are, who are online with us now. So what kind of drinking water utility do you represent? Are you a for-profit, a local government, not-for-profit, some other kind, or not a water utility? And I can see the answers are coming in now, and we're going to throw the answers, an illustration of them, a graphic of them, up on your screen in just a minute here.
Great. It looks like a majority of people have clicked in their votes, so I'm going to close the poll and share the results.
Thank you, Lisa. And as you can see, we've got a lot of local government systems and a lot of folks who are not with a drinking water utility. Imagine probably some consultants, some engineers, maybe a few folks from wastewater-only systems. But let's go on to our next polling question. For those of you that are drinking water systems, we're interested to know what size system you represent. In this case, by the number of people served, not your number of connections. So whether you are a very small, medium, large, or again, not a drinking water utility. And for any of you who are responding to the polling questions, you can use that polling function of GoToWebinar as opposed to typing the answer into the question box, by the way.
Okay, here are the results from that question.
Excellent. Well, a lot of you who answered that, not a drinking water utility, makes sense. But those of you who are, it looks like a fairly even spread between your different size utilities there. Glad to see that a substantial portion of you are serving 10,000 or fewer people, which is the focus of our project. We've got another quick polling question for you. So if you are a utility manager for drinking water utility, do you regularly see copies of your energy bills? Probably that's largely going to be electric bills, but if you have any other kinds of energy bills that pertain to your drinking water system, you could be thinking of that as well. And it looks like we've got a lot of good answers rolling in here. And any moment now, Lisa will show you the results.
And here they are.
Excellent. And a lot of you not water utility managers, but of those of you who are, it's good to see that a clear majority of you are looking at those energy bills on a regular basis. For those of you who are not, after today's webinar, you might see some more incentives to do so. And now I'm going to introduce to you Steve Jones. Steve is a principal at Hanson, Allen & Luce Incorporated, which is an established civil engineering firm based in the state of Utah, focusing on municipal engineering, water resources, and the environment. Steve has more than 15 years of experience working on master planning, design of gravity and pressurized drinking and secondary water systems, storm drain systems, sanitary sewer systems, the analysis of drainage runoff, and I could keep going. Steve's got an extensive resume in this area, and including in the first round of the Small Systems Project, he's helped many water systems identify inefficiencies and develop sustainable solutions that provide substantial savings. I'm going to turn it over to Steve now to talk to us some about his firm's experience and case studies of helping systems like yours save on energy.
Thank you, David. The main point I want to get across is that through my experience over the last 15 years or so of helping water systems be more efficient is that there's significant opportunities to save money. And so start collecting data and organizing your energy management teams and finding that money. I started out doing hydraulic models for master plans. And as I got into the extended period hydraulic modeling, I started seeing these interesting operation similarities and things like pumping in circles and not utilizing storage, peaking off sources. And I just thought this can't be very efficient. And so I started getting into what I called system optimization studies. And you can see my Gantt chart there that I focus on saving energy and saving money, but at the same time we're looking at water quality and the level of service. We can't sacrifice water quality or the level of service or the hydraulic performance of our systems going too far into energy efficiency. So it's a balance between all those things. And in reality, most times when you fix inefficiencies, you actually improve system performance and improve water quality. So that's exciting. So now that over the last couple of years, I started also getting into water and energy audits, and then started helping power companies with their efficiency programs. The last I counted, I've helped over 40 water systems directly, and then countless others through the UNC Environmental Finance Center, through rural water associations, through state divisions or departments of drinking water. It's getting very exciting, being able to help people find inefficiencies in the water system and at the same time save money, this untapped source of money. And so going to my next slide, the results. For several years I was just preaching this and doing the studies, but it's exciting now to have lots of results. Usually what I see is that all systems that I look at, 5 to 50% in energy cost savings, and that's regardless of size, large or small. And EPA Region 9 just did a pilot study not too long ago where they showed an average of 17% energy savings and an average of 26% in energy-related cost savings. And those are right in line with what I see. Even the most efficient systems that I look at, if they use energy, there's at least 5% of available energy efficiency measures they can take to save money. And most is in between that, and there's several that are in the order of 50% savings potential there. And that's through no cost, low cost, and capital improvements. And usually it's fairly well split between the no cost and the capital improvements, which is exciting. There's a lot of things that could be done with that no cost to you, and that's basically what we're focusing on today. Just taking the step to look at your bills, to start noticing how much energy is going on, and taking steps to change that with very low upfront capital. Some of the common strategies that I look at, and I don't want to focus on these too much. I want to let Doug and Don talk about those, but taking advantage of rate schedules for on and off peak and demand benefits, identifying energy use and use lowest cost water first, identify and stop the unnecessary release of pressure. That includes the pumping in circles, etc. Using a storage like a battery, and then pump station and well modifications, finding the energy savings there. So just two quick case studies I just want to throw out there, and then let Doug focus on his. But Logan City, we just did a small project for them last year, where we basically created a new pressure zone and modified 2 wells, and we've got back exciting results from a year later, where they've saved 32% in energy costs. They used 17% less water, and that's not, they didn't use less water in the system. It's just because of the pressure reduction, less water leaked out, and which is exciting because that's on top of the energy savings. And then they had 40% fewer main breaks, and so they're able to put more resources towards maintenance and more productive things than running around and fixing main breaks. So exciting for one little project, and there's much more to do in this city to save energy. Another quick one, Spanish Fork City, where again we did a project to preserve pressure from Mountain Springs. Again, reconfigured some pressure zones to eliminate pumping, and again, $200,000 of annual savings. So the money is out there. These are kind of the bigger ones, but there's significant money in just the no-cost, low-cost items also. So my last slide, before I finish, and this is what I've been struggling with over the last 10 or so years, are these barriers. This is from a AWWA presentation or a publication a little while back, but these are real. The lack of awareness, where operators may not be used to thinking about energy. So utilities must understand benefits, cost arguments for doing so, and then the risk. Deviating from the usual routine creates risk, whether perceived or real. That's a real barrier. And then the change implies a problem with the status quo. Sometimes it can be hard to say, hey, this pump station, it just wasn't designed for energy efficiency. It's sometimes hard to tell systems that it might be done wrong. And then just the cost, probably the biggest barrier. It's hard to spend the time and the money to identify energy efficiencies. But once you do, obviously the benefits are just overwhelming. And so that's the end of my presentation. And now I'll let Doug present his case study.
Thanks very much, Steve. And I'm going to say a quick word to introduce Doug, and then he will take it away with his part of the presentation. Doug Evans is the Chief Technical Officer at Mountain Regional Water District, a governmental water entity that serves the Park City area of Utah. Prior to that time, Doug managed a water district for Salt Lake County for over 20 years. Doug helped establish the Mountain Regional in January of 2000 with only 300 customers, but it's since grown to nearly 5,000 customers. And the district is a rationalization of otherwise failing or struggling water companies. The district serves a vertical extent of over 3,000 feet with many pumps, pump stations, including some with some significant horsepower, which has placed energy management and conservation as the paramount operational goal of the district. Doug and the Mountain Regional Water District have realized over $300,000 per year in savings as a result of his energy and conservation management strategies. And Doug, like Steve, were a big help to us during the first round of the Small Systems Project. So thanks very much for what you're about to share with us, Doug.
Thank you. Mountain Regional is a district that has a significant amount of power and energy cost. We're about $1 million a year in energy costs if we weren't doing any conservation. And so it was necessary to look at some of these things and especially start with some of the easy things first. And
Doug, I apologize to interrupt you right there. I think we may not be seeing your slides at the moment. Do you have a little box you can click on there to change you to the presenter? Are you seeing that on your screen?
let me check 1 second.
Sorry about the interruption there, folks.
Remember, Doug, click somewhere, anywhere on your control
Change
panel.
presenter.
Yes, just should be able to accept the pop-up window. So,
There. Do you see it now?
yes, great.
Yes. Thanks, Doug. Please continue.
Sorry about that. But the immediate steps we took was to evaluate our energy bills. And we realized that our power utility was not automatically putting people, especially water utilities, on the most efficient bill. And by studying, and everyone will have different bills, but they'll kind of be similar. By studying how your system operates, you're able to, and understanding your local rate tariffs, you're able to pick a rate that is much more effective. And simply changing rates on some services so that we could go off peak and pump at night allowed us to accumulate enough money to fund a lot of the other energy efficiency measures we wanted to take. So evaluating rates and learning about them is a continual process. Going off peak is something that we can do in water utilities that no other industry can do, where we pump at night. And in order to pump at night, we have to do what Steve talked about. We have to use our reservoirs more as storage batteries. We have that ability better than anybody, and we have to allow our reservoirs to drop more so that we can pump in these optimum times. I'm not talking about dropping them to levels that are dangerous, but we have to deviate from a standard that our operators are used to. The other thing we noticed, which I have noticed as I've talked to many other water systems, is pumping stations and wells operate on a very short load factor, meaning they only pump a small portion of the day. Sometimes less than 20% of the day is used in pumping. And when that is done, we pay much more in not only a power demand charge, but we also pump more water quickly and burn up more energy because of head losses in our distribution systems. And I'm going to talk a little bit about that. Has been a big thing that we've learned. We also found out modeling our system, we found many leaks and potential circulation of water. We've also found out that a SCADA change is sometimes necessary to implement energy management changes. One of the first things we found we had to do was prioritize our project. And I like this slide because sometimes a rate change is just those quick hits in the lower left corner where we evaluate our priorities based on the effort or cost on the left side and our energy savings on the x-axis. And sometimes a phone to the call to the power company can result in a quick hit. Changing how we operate pumps or what times we operate can be sometimes those gems where we get a higher savings with very little effort. And then as we accumulate savings from that, we can invest more in the capital projects down the road. What we try to avoid are projects that require a lot of cost or effort but have very little savings. This is one of the first things we did. This is a chart of our sources and pumping stations, and of just our pumping costs over a certain period of time, a couple of years. And if you look at that chart, you would immediately think there's these three tall bars that would be our costly sources. But if you go to the next chart and we compare the cost per million gallons pumped, and we call that specific energy, now those ones that were tall in this previous slide are much lower. And this allows us to prioritize which pumps or which sources we run, and some we simply don't run anymore. And this was a real eye-opener to our staff and our operators when they saw what this chart looked like. And I'm also showing energy and power in this chart. This next chart shows what a typical pump station or well in our district would use when you look at the on-peak and the off-peak kilowatt hours. This will be typical of many of our pump stations. On-peak is in blue and off-peak is in green. You can see at the far right, we decided to start going off-peak with this particular pump station. So you see the off-peak, the on-peak load drop considerably. This is more what a pump station in our district would look like if we were totally off-peak. Now you see the off-peak being the pumping load, and that little blue line at the bottom is simply lighting and heating. By going off-peak, we were able to save several $100,000 simply by how we operate our pumps. This is kind of a pattern that we look for in success, this little chart. This shows in the blue trend, you see our gallons pumped over about the last 7 years. And it's increased considerably, and you can see the linear dotted line showing that increase. Incidentally, that dotted blue line also tracks well with the increase in energy costs in Utah. Our local power company every year has been jacking up costs. The red line is the total cost per 1,000 gallons. And you can see how it drops even during continual rate increases. And this is really kind of the sign how we want a water system to look when they've implemented these programs. This is a typical system in Utah that is just beginning to get into energy management. I'm not going to name the city because they may be on the call, but this is classic. They're trending with the continual rate increases, and their average per kilowatt hour for their whole water system is about 10 cents per kilowatt hour. This is what our system looks like when you take all of our pumping facilities. We're down to 3/4 of that, and we're dropping. This is kind of the last slide. This is the bottom line. A couple years ago, our bills would have been about $875,000. We have since knocked off. Initially, we got down to about $300,000 in energy management. We're about halfway into the green pie and somewhat a little bit into the purple one, where we've been doing some other projects. So we're actually now pushing $400,000 a year. We've chopped off that, so it shows the remaining energy. We've almost cut everything in half through simple energy management. That's all I've got.
Thanks very much, Doug. And again, everyone will have an opportunity to ask questions of all of our panelists towards the end. Right now, I want to introduce my colleague, Don Nall. And Don has a BS in chemical engineering from the Rose-Hulman Institute of Technology in the state of Indiana. Dawn is a licensed engineer intern. Her experiences include working in many ways, including as a wastewater treatment plant operator, a manufacturing engineer, design engineer, and is currently a program manager working with the Wichita State Environmental Finance Center. Dawn has designed and overseen construction of water treatment and distribution systems and wastewater systems as well. Has worked with federal, state, tribal officials, and many others. Since joining, Dawn also works with another one of our environmental finance centers, the Southwest in New Mexico. Since joining them in 2006, Dawn has presented trainings around the country to water and wastewater systems on topics including asset and energy management, rate setting, capacity development, construction cost estimating, water treatment, operations and maintenance, and operator certification. Dawn has also been involved with the network in various other projects such as leak detection, green projects, source water protection, and many others. And Dawn, take it away.
All right, thank you, David. So we're going to kind of get into the bread and butter here of energy management for small water systems. And today we're going to look at teams, baselines, and data. So should a small water utility care about energy? I think that we've talked enough today to hopefully grab your interest, but here's a little graphic that shows an example of a typical water utility's O&M cost. And you can see that the energy expenses are 30% of their O&M cost. Would you like to make that slice of pie smaller for your water utility? And then here are some simple statistics regarding how much electricity costs are for pumping water at small systems each year. And you can see that there's good potential by reducing your use by 1% and 10%. So what would it take for your water system to reduce the electricity consumed by 10%? And how much would you save? This is a checklist that was developed by the New York State Energy Research and Development Authority. And it was developed for small water systems to use to determine if there's potential for energy reduction within their water system. The checklist is available. I've listed the website there at the bottom of the page of the slide, and you can go there and download the checklist and use it. It is a list of 6 topic areas, and it asks a series of yes or no questions to help you determine if there's potential for you to save at your system. There's also a checklist for small wastewater systems. So each of the categories has the yes or no questions, and if you score more than 5 points on the list, it means that there's good potential for your system to save energy or to reduce your energy use. And each of the questions, the points may be for yes or for no. So for example, it will say, do you have low lift pumps? If yes, you get 1 point. If you do have low lift pumps, do you have variable speed control on the pumps? If you answer no, you have 1 point. If you do have low lift pumps, are your low lift pumps equipped with premium efficiency motors? No is 1 point. So you can see that each category has a set of questions, and you can answer yes or no and determine if you have potential to reduce your energy. This is the remaining 3 categories. So there are questions about disinfection, residuals management, and other questions. So again, for example, does your plant currently haul residuals to another location for processing? Yes is 1 point. Are your residuals currently used as part of a beneficial reuse program? No is equal to 1 point. So you can go through the checklist and get an idea if you have a good potential to reduce energy. And if you score more than 5 points, there is great potential to reduce energy use. So if your system has potential for energy savings, and you can agree with that one of your goals is for your water system to provide services for reasonable and fair user fees, then one of your goals is also reducing your energy use. So how do you go about getting started? NYSERDA developed a 7-step approach for water and wastewater systems to implement an energy management program. They have a best practices handbook, and it can be found at the web page that's provided here. Several years ago, when the EFC started researching energy management for small water systems, we determined that NYSERDA's program was clear and concise. There are other approaches to energy management available. We selected this program because the primary goal of this approach is to ensure that energy-related decisions are well thought out and that all stakeholders involved understand the reasoning behind any proposed changes. So who is NYSERDA? Here's just a little bit of information about them. It is the New York State Energy Research and Development Authority. You can see their mission statement, and their municipal water and wastewater sectors are a target to strategically reduce energy consumption in New York. Their information is all available, all published on their website. It's all free. They're very willing to share and to help other systems. So we're very grateful to them for sharing their information. So the EFCN is hosting a series of workshops and webinars focused on energy management, as David mentioned. And all of our webinars are made available on our website, which you can see at the bottom of the slide, the web address. Today we'll be focusing on the first 4 steps of developing an energy management plan. So that first step is to establish organizational commitment. How do you get a team? So we want step 1 to focus on building a diverse project team, and you want that team to be committed to supporting your energy management process. When you talk about energy use and energy reduction, it cuts across many organizational boundaries. So it's important to make sure your team is diverse enough to understand the wide variety of issues and the needs that come up with energy use reduction. The specific level of effort required by the different team members will probably vary throughout the process, but it's essential that you maintain their commitment. The size of the energy management team needs to mirror the complexity and the size of your own utility. So the team needs to be large enough to represent different perspectives on energy use, but you don't want it to get so big that it becomes burdensome or cumbersome so that you can't accomplish anything. So you want to make sure you have a good balance. Who would you include on your energy team to make sure that it's diverse enough to cover the wide areas that energy topics cover, but not so big that it becomes cumbersome? Would you want to include an elected official, a decision maker, a manager, an operator, someone from the operations staff, a member of the finance team, someone from business management, someone from engineering? Can you think of other people that you would like to have on your energy team? Step 2 of the program is to develop a baseline of energy use. So what do you need to do to develop an energy baseline? Well, first, we want you to focus on the information that's readily available to you. We want you to take that information and organize it into a basic model that can help you understand your energy use patterns. And then we want you to communicate those initial findings. So you need to collect and organize equipment, energy use, and hydraulic data. You need to develop an understanding of where, why, and when energy is used. And then you can create a baseline of energy use. And we want you to understand your energy bills and the rate structure that's used to set your energy costs. In this step, you'll be taking actions like gathering the information. You need 1 year of data as a minimum, and this data would include things such as utility billing records, SCADA system records, O&M records, equipment or motor list, anything that has horsepower or load list. And then you want to organize those treatment processes by functional area. You want to evaluate your energy bills and understand the rate structure. Review your hydraulic data, your flow data, and compare it to your energy use. You want to identify any wet weather patterns or any seasonal patterns that you might have and build that basic model. You can then create graphics and report your initial findings and your early successes. Don't get overwhelmed. Start small and grow the level of complexity of your information gathering to match your goals. Once you have your initial findings, use those to determine what information you need to gather in the future. And make sure that you're communicating your successes. Communicate those early successes. Why bother collecting all this data and communicating your early successes? Well, we know that energy efficiency gains are equal to money saved. And you can save money early on just by going through the process of investigating your use. It's been shown that improving awareness among staff can provide measurable energy efficiency gains on the order of 3 to 5%. So no capital investment, just that initial investigation of your energy use, and you can see quick gains. Those quick gains can be used as an early victory so that you can demonstrate value in the process before any significant resources are committed to the program. As part of step 2, we want you to understand your electric bill. We asked a poll question about who gets to see their energy bill. So do you get to see it? And if you see it, do you understand what you're paying for? It seems like oftentimes some small water system managers might not ever see their electric bill. They put a line item in their O&M budget, and it's based on what they paid last year or how much rates are increasing this year. But it's not based on where and how electricity is used. So seeing and understanding your bill is an important part in controlling your expenses. When you look at your bill, you might not know what all you're looking at. It might not be clear what all of those charges are for or how they're used. So let's talk about some of the terminology used. The cost of electricity is based on 2 main components. First, how much electricity are you using? The quantity of electricity in kilowatt hours. That's your consumption charge. And then the demand for electricity. It's also important to note if you're on peak or off peak, those consumption times can affect your rate significantly. So understanding the electric utilities pricing structure or pricing policies, their rate structure, is critically important to making progress in energy management. So if we look at the specifics, electricity is measured in kilowatt hours. So that's 1 kilowatt hours, or 1 kilowatt hour is 1,000 watts used steadily for 1 hour. That's the measurement of the rate of electrical energy used, multiplied by the length of time that it's used. So the larger the power rating of your electrical equipment, the higher the kilowatts, and the longer you use that equipment, the more kilowatt hours you will consume. So I've got a little example in the bottom left there. If you have a small 5 kilowatt motor running for 10 hours, it would use 50 kilowatt hours, while a larger 50 kilowatt motor would only have to run for 1 hour to use that same 50 kilowatt hours. A kilowatt hour meter keeps track of the energy that you use in a billing period, and that billing period's typically 30 days, but it can be different depending on your provider. And the energy charge is designed to recover the variable costs. So you need to be familiar with how your pricing schedule is. If there's blocks of energy, if it's a flat rate, which isn't very likely, if you have peak charges, things of that nature. And then there are the demand charges or the power charges, and those are also measured in kilowatts. And this measures the capacity of the rate at which you use energy. So it represents a number that's the greatest amount of energy used, and typically it's in a 15-minute interval during your billing cycle. So to measure the demand, the meters record the average demand over each 15 minutes, and they record that highest period for the month, the peak. So 2 customers could use the same amount of energy, but the one with a higher demand would have a higher bill. So I have another example down in the lower right corner. If you have 2 businesses that both use 2,400 kilowatt hours per day, and one uses the energy uniformly during an 8-hour day at a constant demand of 300 kilowatts, they still use that same 2,400 kilowatt hours. The other business operates 24 hours a day, and they consume a constant rate of 100 kilowatts. So again, that same 2,400 kilowatt hours. So even though both businesses use the same amount of energy, the first one places 3 times the demand on the electrical system and needs 3 times the generating capacity. So the peak demand charges would be higher for that system that has the 300 kilowatts over 8 hours. So that's why it's important to understand how your system's using energy and to control your peak demands. So the peak demands can typically be 30 to 60% of the overall cost of electricity. You can lower the variability in electric demand over time, flatten out your demand curve by minimizing changes in peak demand, and by shifting loads from peak periods. Peak periods are oftentimes daylight hours, so if you can shift to operating in off-peak periods, you can make a significant difference. And you can find these cost savings by doing things indirectly, by having supplemental storage tanks, the battery that we talked about earlier, or by shifting loads to off-peak periods and minimizing the overlap between treatment processes. Another thing that we want to do in step 2 is to build a model to benchmark. And there are several benchmarking tools available publicly. I've listed a few here. And benchmarking tools help you to track your performance over time. That would be internal benchmarking or comparing your performance to other similar facilities. That's external benchmarking. External benchmarking is readily available for wastewater systems. For water systems, it's a little bit harder. But the reference that I have listed at the bottom has tried to take away those factors, kind of normalize those factors, and has given a scoring system. So you can compare, you can do some external benchmarking for water systems. I've listed the websites for each of these benchmarking tools. So EPA's Energy Star Portfolio Manager is available online. It's an online tracking system. And Energy Star offers many types of trainings, and they're going to hold a couple of live trainings coming up here in just a couple of weeks for Portfolio Manager 101 and 201. You can find their trainings listed on their website at energystar.gov/buildings/training. And here's the website for NYSERDA's and the website for AWWA's document. Step 3 of the process is to evaluate the system and collect the data. So this is where we're going to do a system walkthrough, do some staff interviews. We're going to gather more specific energy performance data. The Environmental Finance Center Network developed this inventory table to help you record the information on your energy using assets. You can use this table or any other format that's easy and acceptable to your team for tracking your energy using assets and the energy that they use. You may also have an energy audit or an energy assessment completed during step 3. Energy audits and energy assessments are slightly different. So to help you collect the data, you would probably want to consider the expenses that you have and where you're at with the process. You can do an energy assessment yourself. You usually would hire someone from an outside entity to complete an energy audit for you. And if you do a system walkthrough with that table from the previous slide, you can essentially gather the data that you need to perform a level 1 energy assessment. When you're looking at doing an energy assessment or an energy audit, there's several areas that you'll want to look into. Things like raw and finished water pumping, chemical mixing, backwashing, well systems, ozonation or UV disinfection, load shifting, distribution systems, your SCADA system, energy efficient motors. And it's also very important to consider and understand the tie between energy efficiency and water loss. If you're treating and pumping water that isn't being sold, but it's leaking out of the pipes, you're just throwing money away. So AWWA has developed a water loss audit spreadsheet, and the EFCN has developed a guidebook that walks you through AWWA's audit process. The EFCN will be holding webinars later this year that discuss water loss, and our guidebook's also available for download on our website as well. If your utility decides to have an energy audit or an energy assessment completed outside of the utilities personnel, there are groups that can provide assistance. So we've listed a few of those here. Step 4 of the process is to identify your energy efficiency opportunities. So once you've completed the first 3 steps, now it's time to start making a list, identifying potential projects. You want to list nearly as many projects as you can think of. Don't limit yourselves initially because you think something seems unlikely or seems unreachable. Green projects and energy efficient projects are often funded differently than the typical capital improvement project is, and we're going to go into detail about that in our 4th webinar. So just make a list of everything that you can think of. Whenever you're looking at energy efficiency opportunities, you want to know that they're defined as any system change that helps to reach a stated energy management goal. And then once we get into the next steps, we'll start to prioritize that list and figure out which ones we need to do first, which ones are cost effective, and the graph that Doug had, you'll kind of come up with something like that to help you figure out where the low-hanging fruit is, where the gems are. And there are several resources. Doug had a great chapter that he wrote in Utah's Drinking Water Energy Cost Savings Handbook, and that handbook is available online. NYSERDA has a list of example projects. Several other sources are available out there, but you want to look at both the building operations and the systems operations. I've just got a couple more slides here. So the categories for energy efficiency opportunities, you want to make sure that you're looking at these areas when you consider any energy efficiency opportunity. Consider capital programs or equipment replacement, process changes, operational changes, all the way down through business measures, maintenance improvements. So those are the areas that you want to kind of consider. There's lots of potential in each of those categories. And now I'm going to hand the controls back over to David. We've got a couple of polling questions, and then we'll open things up for questions.
Thanks very much, Dawn. We do want to capture from all of you just a couple of things here, and let me get to, sorry about that, the right slide there. So we're going to launch a polling question now to ask you about if you would be interested in subscribing to the Environmental Finance Center's blog here at UNC-Chapel Hill. If you say yes, we're just going to sign you up for our blog. We are not going to try and sell you anything or turn over your address to, you know, anybody else for other purposes. It's just a place where we write from our research and our applied work we do with systems for water, wastewater, stormwater, energy, and solid waste work that we do here. And we'll give you a few more seconds to respond to that, to capture the people who are interested in signing up for that. Okay, and Lisa, if you'll close that poll now, and we'll go on to the last polling question we have to ask you, which is, are you interested under the Small Systems Project in receiving some direct technical assistance? Now, you do need to have a drinking water system, and you do need to serve 10,000 or fewer people, not the number of connections, but the number of people served. So if you are interested in that, click yes. If you're not sure, would like to request more information about what's involved, click that button. Because this is funded through the cooperative agreement with the U.S. EPA, there would be no charge to you, though typically we do need some of your time and your effort to help explain your needs to us, collect some data so that we can do some analytical work and some assistance work for you. And Lisa, let's go ahead and close that poll as well. And now we do have a number of questions from the audience. I'll get through as many as I can. Doug, this question is for you from Steve, and he is wondering, I think you had about $300,000 in savings there. How much did you have to spend to get that savings, or is that already the net amount?
Of that $300,000, I probably had to spend $5,000. And most of that was just time studying the rate, different rates, and how we pump.
Very good. Well, thank you, Doug. That sounds like a good rate of return. We also have this question from Paul, and I'm going to direct this initially to Steve. have you looked at restoration for any of the systems you've worked with of existing pumps to optimize performance, i.e. reduce energy costs? And if so, have you considered sandblasting and then coating the interior of the pump as part of the restoration effort?
I've looked at just about anything you can think of as far as trying to save energy. I can't say that we specifically have done that. Usually it's replacing or modifying pump stations.
For fire services from your system, how do you balance those things?
We never want to cut into any fire or emergency protection. That kind of goes back to one of Steve's slides. We have to maintain the levels of service and safety with any program we do. But what we've found is there is a lot of capacity available that you can use for energy management before you get into that area.
Very good. Thank you, Doug. And this question I'm going to direct to Dawn from Joanne, who says, our electrical utility tells us that the demand charge is not impacted by the time of day use. Therefore, we are not sure how to determine how to impact the demand charge. Does this sound correct?
I think that what you would want to do is start to look at your data and your use and see if you can reduce your peak. Your peak will impact your demand charge, and reduce it if you can reduce your peaks. So even if the demand charges are not specific to a time of day, reducing that peak number will impact your demand as well. So I think that you would want to look at where you're using your energy and how you're using your energy. And Doug, you might have some comments on that too.
Generally, nobody's existing rate will allow a benefit for off-peak. You have to change your rate and request that you go on a different rate tariff. Most utilities will have an off-peak rate, but you're not on it automatically. You need to study it and switch to it.
Thank you, Dawn and Doug. And I think we have time for one more question, and then we're going to send to your screen a request for you to fill out a evaluation of us here. I'll mention that again in a moment. And Doug, I'm going to send this one your way from Fernando. Is it economically feasible to use water flow in pipes to generate energy?
It only is if you've got the energy that you can use. If you're going to pump water and then extract energy out of it, it won't be as efficient. But if you've got, for instance, if you're feeding a city from a spring on a mountain and you've got that energy to use, it may be worth looking at that.
All right. Well, thanks very much, Doug. And you should be seeing pushed out to you now from Lisa a link to a quick survey. It'll only take you a few minutes. If you have time to fill it out now, we would love that. If you don't have that time right now, there will be a follow-up email to all attendees with this survey link, as well as a link to the presentation slides and the video recording, and you should receive that in the next day or two. I know there's a few questions we don't have time for right now, but we do want to end on time, so we will be following up with y'all offline to get you answers to those questions. I want to say thank you very much to all of my colleagues here for your time and your expertise today, and to all of our attendees from around the U.S. and a few of you abroad. And please tune in for the third and the fourth installments of this energy management webinar series in the coming months. Thank you very much, everyone, and have a great afternoon.